This is hopefully the home stretch now for the workshop power supply unit. Just got a bit of soldering up to do, so I'm going to use a 2x8 board, and I'm going to have the VCC coming in here. Let's use a 3.3 volt as an example. There's a little bit of headroom needed, so the switching power supply will provide, I'll just want it to maybe 6 volts, and then that comes into a rocker switch. So that will say, okay, I want the 3.3 volts. Then downstream of that, there'll be a 100 nanofarad capacitor as per the data sheet for the LM338. Now, the adjustment pin on the LM338 is a voltage divider, so I'm going to go with a 500 ohm voltage divider there. I was originally considering like a 10k one, but I couldn't find any 10k's ones with these handy dandy winders on the end, and I much prefer that to the ones where you wind on with the screwdrivers like this. So they're a bit fiddly, but these little guys with the winders are fantastic. So we're going to go with the 500 ohm version, and the voltage divider then is completed with this, well, in this case it's going to be around the 270 mark for the resistor coming out between the adjustment and the output. So that's that guy there. Then the output will just go out straight to the outside of the 3D printed box. What else is going on? Oh, between output and ground there is a 1 microfarad electrolytic capacitor, again as per the data sheet for the LM338. And also on the output here, I'm going to have a 1K resistor, that's this guy, between the output and the N-channel MOSFET, the BS170. So it'll sit in here, and that should allow flow from the output. So let's say 3.3 volts. A suitable resistor would be 330 ohms. That should produce around the 10 milliamps for the LED. There's the 330, there's the LED, and that should indicate that the circuit is live and good to go. So yeah, and then the other requirements here for the other voltages. So again, using that 500 ohm pot, we've got 120 ohms ish to provide 5 volts, and I'll be using a 500 ohm resistor for the LED, the indicator LED. And for the 12 volt one, with 500 ohms, we've got 43 ohms ish on the voltage divider. That's this guy here, and then for the output, well, for the indicator LED rather, 1.2 kilo ohm resistor for that. So let's get one soldered up, test it, and yeah, we're good to go. Well, that time lapse took a ridiculous amount of time, used up all the space on my iPad, and was frankly pretty boring anyway. So skipping to the end product for the 3.3 volt version, the only addition probably has been this splayed heatsink on the LM338. But what we've got is 19 volts coming into the switching regulator, and that needs to be a little bit of headroom above the 3.3 that we want. So I've got that set at 6. So it's doing the majority of the efficiency in terms of going from a higher voltage to a lower voltage, so from the 19 to the 6. So not dissipating a huge amount of heat by using switching, but of course the whole idea of this is that you know, there could be a little bit of ripple associated with that, and so it goes to this linear voltage regulator. These wires look ridiculously close, but in fact there's quite an air gap there, so no panic. Yeah, so let's turn it on. So this switch will be at the front of the PSU, and that via the MOSFET that's here gives the LED indication that this circuit is now live, and there's the 3.3 volts coming through on the output wires, which are here. And of course, if any adjustments need to be done, there's this little handle here to wire that up or down, and that adjustment is pretty easy. I'm going to put that adjustment inside the box. I'm not fiddling with it constantly, but yeah, I'd say that is pretty much working now. So what I need to do is to wire up the other two, the 5 volt version and the 12 volt version, and in the background I'm printing the PSU box. So I think by the end of the day, we might have ourselves a workshop PSU. Yeah, getting closer to finishing this now with the connections for the 3.3, the 5 and the 12 volt all connected up. Just need to put in ground and yeah, pretty much good to go. It's a bit of a rat's nest, but the color coding helps. So we're all boxed up now and it's looking lovely. I think I'd probably change some of the design features. I think these are conventionally the other way around. I would probably spread them out a little bit further and maybe put the LEDs closer to the switches and the switches and LEDs a little bit over this way. But look, you know, a little bit of this, a little bit of that, no big drama. All right, let's test it out. So it's currently off at the side. So there's a little button at the side here. Okay, so that's off. And what should happen is this is live though. The 19 volts is live. So when I put it in here, that little blue indicator light should go on. But nothing is live, so I should be getting nothing out of any of those. Let's have a look. So, yeah, nothing, 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 and nothing. Excellent. All right, now we turn on, and we have a display, but again, none of these should be live because it's not on at this stage. So just checking all of these. No, no, no. Excellent. All right, so the first thing to do is to program up some voltage. So that's 8 volts. Let's start with the 3.3. Actually, no, let's start with the 12. So I'm going to bump this up to 15 volts to give the LM338 a little bit of headroom to do its magic. And it's current limited at 0.2 amps and we're on. So 15 volts is coming out, and at this stage it should only be coming out of these ones here. Yep, 15.02 is good. These should still be all off, and they are. That's nice. And then we go to turn on this one here, which is our 12 volts. Little indicator light comes on, that's good. This should be 12. Yep. This should still be 15. Yep. And these two should be dead. Yep. Nice one. Okay. Now, if we want 5 volts, we need to wind this down a little bit. So I'm going to change this to maybe 8. Let's wind this back. Oops, wrong way. 8 volts is good. And it's already on, so let's get this. Yep, 7.99. None of these should be live. Don't think I just need to keep testing that, but anyway. Nope, it's all good. Now we switch on our 5 volts. And we're getting 4.99, 5 volts. Over here still 8. And these guys should be dead. Nothing and nothing. So far, so good. All right, and our final one is 3.3 volts. So let's dial this down to 5. And we're good. So 5 volts at this end. Yep, nothing out of these guys. Nope. And then on for the 3.3 volts. Lovely. And nothing out of these guys. Fantastic. Wow. Okay, so a little bit of hot gluing to be done, but you guys don't need to see that. It's always horrible. But that is the circuit working. That is a lovely, lovely project. And I'll put all the links in the description below for the other, I think this is the 5th of the series, with all the experiments and all the failures along the way. But I will say one thing, if I can do this, anyone can do it. What a great project. See you next time.